purpose of this exercise is just to show you that the same equation in x and y could be considered as an equation in two variables and in 2D, and what we call r squared, real numbers squared, or it could be in R3, and in each case it would represent a different shape, get an extra dimension in each of part B. So in each case, they're giving you an equation in x and y, and we want to interpret it in 2D and in 3D. Don't want to get too technical, just wanted you to write to see if you can identify the shape. Well, in 2D we've learnt about equations like this, linear equations. This would be a line. I could even sketch it if I let x equal 0. Well, why don't I, in fact? If I let x is 0, then I'll get that 3y is 6 or y is 2, and the other way, if y is 0, x is 3. So if I just do something rough like this, we said that when x was 0, then y was 2, and when y was 0, x was 3. So we get some kind of straight line here. This is y, this is x, and that's our line. Here's 2, here's 3. Now, if I was looking at this as an equation in 3 dimensions, x, y, z, and z just happens to be missing, what we do is we just add a third dimension. I can't really sketch it here, but through each of these points on the line, we'll take a vertical line perpendicular to the plane that we're seeing, and so what we actually get is a plane. So here I just wanted you to identify this as the equation of a line, but in 3 dimensions it's the equation of a plane. It's actually a vertical plane. It's parallel to the z-axis, which is a vertical line through the origin, and that's all. In part 2, just if you studied a little bit of implicit equations and circles, you should recognize that this is the equation of a circle. Not that it's important, but as a matter of fact, we even know the center. It's 1, 0.